regulatory frameworks and standards for agricultural robots, what is the state of art? And I'm very happy to welcome on stage the organizer and moderator of this roundtable, Monsieur Stéphane DURAN, project manager of RobAgri. Thank you for welcoming Stéphane DURAN.
Hello, good morning. So I'm project manager for RobAgri. And first, we have we have 4 people, major player that I'm going to introduce you. We've got first Dr. Ivo HOSTENS, which is technical director at CEMA, European Agricultural Machinery Industry Association. So thank you, Ivo, to join us on the stage. And you can give a warm welcome to Ivo. Marta CEBOLLERO-ARGUIS should have been there. She's from the European Union. Unfortunately, she couldn't attend because of a late plane due to strikes. So you will be able, if you are here tomorrow, to ask questions to her, but she couldn't attend this meeting. We've also got José BRAMBILA-MACÍAS, which is a program manager, trade and agricultural codes and schemes for OECD, the Organization for Economic Cooperation and Development. We've got Mike PANKONIN, which is Senior Director for Technical Safety and Services at IEM, which is for the US, the Association of Equipment Manufacturers. And then from Australia, Rohan RAINBOW, which is CEO of a company named AGTECH, and he's got a lot to say to us about robotics and AGTECH. So welcome to this roundtable, and thank you for being with us today. So I'm Stéphane DURAN, project manager at RobAgri, which is the French Robotic Agricultural Association. Today we will deal in particular with the evolution of the regulatory frameworks and standards as to keep a high level of safety. Safety is one of the main priorities for manufacturers, norms, institutions, and governments. As an example, our association makes contributions on safety to CEMA through a joint group with French syndicate CEMA. For all agricultural robots manufacturers and for RobAgri members, safety has to take into account the interaction of the machine with its environment. The environment can be represented by a person, whether it is a user or an unpredictable person getting closer to the machine, for example. So safety approach also concern damages caused to animal or property. This approach is also used, has always been used by tractors and agricultural machine manufacturers. These institutions and companies apply the machinery directive, for example, 2006, 42 AU, and many other norms, relying on a risk analysis. So do the robots manufacturers. So in fact, what differs for autonomous agricultural robots? In fact, they show very high level of automation, and this is the part that needs to be covered with the evolution of the legislation and machinery directive, for example. In fact, to go a little bit more in details, we know that autonomous agricultural machines are emerging, but they all differ in size, weight, and the task they perform. So they are different, and they may need, on the whole, a more advanced approach. And we also know that a few norms, such as ISO 18147, just came this year, and they address the highly automated machines. But we know that we will need other norms. So we can say the regulatory framework is in a constant process. That's what we're going to see today. We're going to see how the actors deal with these points. For example, we will talk about the responsibility. Is the responsibility the one the user's one or the manufacturer's one? We will also talk, for example, about cyber security. If you want us to point this a little bit more. So for our presentation, each stakeholder will briefly present its way of the way it goes in his country, the state of art, and the ongoing discussion. And we'll have an outlook, an interesting outlook on the US and in Australia, apart from the European side that concerns you more. So thank you, and welcome to Ivo HOSTENS from CEMA.
Too many buckets. Anyways, thank you, Stéphane. So while he's getting the remote, I can already explain who I am. So I'm technical director since a few years, but I'm working already since 10 years for CEMA. And it's actually since the exhaust emissions legislation that we start seeing that we need to be more proactive. And that's also why in the last 3-4 years I've been very active in digital farming, so agriculture 4.0, and certainly to get our industry as a main player and a main contributor to the necessary standards regarding the exchange of information, cloud to cloud, for instance. We're working on these. Robotics is one of them, and also AI. We have started up a kind of ad hoc group to discuss what does it mean for our industry, and can we have some use cases to indicate a bit better what it can mean and what should be regulated, yes or no, for our industry. Maybe first to give some bit of a side of the future of robotics. And I think a lot has been said already in the previous sessions. But I'm talking, of course, from a more political perspective. You know, I have to work in Brussels with decision makers who also look, of course, in ways of, okay, how do we need to regulate, if any? And in Europe, certainly, they try to run ahead of things, to analyze it, to understand better in advance before anything else is there. They just don't say, okay, industry, go ahead, and then maybe later on we will see if we need to regulate something. They want to be always in control of what's happening. They have a certain point, and it's certainly the way that they deal with it, and we have to take that into account. So our vision on this, or I would say our message on this, is there is no fight in this. So this is not about, certainly when you look at it from like common agriculture policy, etc., and environmental point of view, there is no fight between big versus small. There is no fight between tractor versus robot, although there are, of course, differences. And in the future, they might emerge these problems or even solutions. And then also, we don't think there is really a fight between robot versus labor. It's rather that labor is disappearing and somehow we need to replace it in order to keep certain practices here. we rather see, and that's also indicated by Professor Pickle, is this merge of technologies, which is on one side you have automation, then you have also the electrification that's coming up. So the central unit of power, which is the combustion engine, will be changed in the future. And if you then have electrification, you can actually distribute the source of the power source between different vehicles. And then, of course, if you add the necessary intelligence, and not only intelligence in one vehicle, but joint intelligence between different systems that are jointly doing specific processes and operations, that's where you get the necessary added value. And that's also what Professor Pickle has indicated, for instance, on that it's the digital farming that will give the added value. It's not purely about, you know, the fact that the robot is there, this will change everything. It's actually that you need to use these systems optimally, and you can only do that if you have insight, if you have the decision power, or that you have the necessary decision supportive tools in order to allow you to use the system in the best possible way. And of course, it has been indicated as well, it's all about optimization of the processes, but it's also about adaptation and flexibility in order to cope with new problems like droughts, with too much rain, etc., that you still be able to do all the operations in the field. What about the needs then for legislation and standardization? We can make the separation between what's happening on the road, what's happening in field. So in field, we say we have the machinery directive in Europe. And it has already found fit for purpose for robotics. That, for me, means the essential requirements that's already written there are probably the ones we need. I don't know of any others that need to be added. The only thing that you can see, of course, in the machinery directive is it doesn't speak about autonomous vehicles. It always, when it goes about mobility, it speaks of a driver to be in control. So there are some things that might need to be clarified. Maybe not in legislation, maybe just in the guide. It's to be seen. But in any case, what our point of view is, you first need to develop the right terminologies, the right requirements from a technical point of view within standardization, before you can even think about moving towards new essential health and safety requirements, for instance. And therefore, it's our strong push towards keeping the machine directive as it is, and hopefully we can keep equal tread with the evolution on the revision of the machine directive in order to give them some support in clarifying how we can include autonomous vehicles there. Then there is another issue that's tractor type approval, because that's, of course, in a completely different way of certifying vehicles. So we need to check how we will deal with that. Will that come under a complete type approval procedure, which is quite heavy, etc., or to keep it as flexible as possible, to leave innovation run its course? Should we not add it on, do a kind of add-on as a kit under the machinery directive rather than under the tractor legislation? So it's not clear how to deal with that. We also are looking at what's happening in the car industry, but a lot of these things are quite heavy, certainly in terms of homologation of the systems. Then when you look at the road itself, what we see as possible options, or you do exactly as the car industry, you just follow their homologations. Or you could have it transported, like a lot of robot manufacturers are doing right now. Or another option would be a virtual connection, meaning that, okay, you have to have the necessary lights, etc., to go on the road, but for the rest, when it comes to the risks for being on road, that's being covered by a vehicle that drives in the front, and that you connect your vehicle by a virtual connection. So he drives at a certain meters behind the vehicle that actually will drive on the road. That could be a manned vehicle, that could be an autonomous vehicle. And another issue, very important, of course, is cybersecurity. Cybersecurity and the issue of trust. So it's not only about, you know, what's coming in your vehicle, that you have to make sure that your system is tamper-proof. It's also about the communication lines. And for instance, messages that are coming in. We're not talking only about information messages, but in the future as well, task messages. Vehicles giving each other tasks. And of course, also coming from outside. It's a central system that you don't manage anymore. It's your fleet management system that's autonomously deciding what a vehicle will have to do. How can you trust that? So cybersecurity is very important, issue of trust. When it comes to what we are doing for the moment, so we started the project about in 2018, and we looked at a number of things. First, we looked more into the practice of how can we support manufacturers in doing the right risk assessment. So we had two standards in draft. One is on levels of automated functions, which looked at the management and the controls of automated functions, but also then looks in like where should a perception system and where should be a supervisory system be necessary, depending on how high you go in these levels, and also requirements for perception systems. How do you choose a perception system? So support actually for manufacturers to do that. Because of course we don't want always to have the highest level of security, of safety. It needs to be the right one based on the state of the art that we know is existing. And therefore we think it should be globally harmonized of what we consider as the right way for a manufacturer to look into this risk assessment. But while we were working on this, we also saw that we need some ethical guidelines on this, an ethical framework to understand the conditions for such a risk assessment, which was, do we look at the other operations in the field as well, or we only look at the movement of the vehicle so that it doesn't run into obstacles, etc., that it takes into account operation versus movement. That also, for instance, what is a field? Field, is that a public area, like a market space where you can run in and people can come all over the place? Or do we say, no, it's not a public area, but we need to take into account that people can actually run inside your vehicle? Also, for instance, you still have levels of autonomy where you have still a driver. So what do you do in terms of giving control? And who's at a certain moment in control? So there need to be also traceability of who is in control, etc. So these things we try to get in a kind of ethical framework. And you see also that there are different requirements that probably still need to be developed. And I think we're still quite far away from these elements to develop then C standards, although they're already existing. So specific designation standards for specific vehicles doing specific tasks. Some of them already exist because they wanted to run ahead because they're very much already existing. But for the bulk of our machines, our mobile machinery, actually we are trying to first work on the global level and then only go into the depth of individual specific machine types. And also that would be the right time actually to look into harmonized test methodologies. So of course, the fact that we want to look global, we are very interested in other initiatives and certainly also collaboration with other sectors that are working on this. So that in short is what we are doing at CEMA. Thank you.
Thank you, Ivo. Then we've got two other slides we can maybe skip on. It was Marta, so telling on the next slides that there was a review of the machinery directive, which was carried out for the moment, and with an expected outcome in 2021. Maybe if you have other question about norms, our panel can and the directive can answer. So now José Brambilla will talk for the OECD.
First of all, thanks for the invitation. I would like to explain you first who we are, what we do, and what is our proposal for agricultural robots. So I work for OECD, and inside OECD we have a program that is called OECD Tractor Codes. The OECD Tractor Codes was established in 1959. Actually, this year we are celebrating our 60th anniversary. We are an intergovernmental organization, and our main mandate is to facilitate trade. In this case, our mandate is to facilitate trade of tractors. So how do we do that? We do that through a common set of standards and test procedures that we call tractor codes. Currently, we have 9 tractor codes, 7 codes that certify the safety of the tractor. For example, the cabs in the tractor, that their strength is strong enough to, in case of an overturn of the tractor, so that the driver will survive those type of accidents. We have 1 code that certifies the performance of the engine of the tractor, and we have 1 code that certifies the noise levels inside the cabin of the tractor. Now, the Tractor Codes program is voluntary. So countries can decide if they want to join or not the program. But once they decide to join, they need to comply with all our rules and regulations. As you can see from the slide, currently we have 27 member countries. So we have China, we have United States, we have Brazil, we have Turkey, we have India, we have Russia, we have most European countries, and we have equivalence with the European Union. What this equivalence means. Today, if you are a tractor manufacturer and you want to sell your tractor in Europe, you have two options. You can go to a European accredited homologation center, and you will get approved there through Europe, so your tractor can be sold in all the European Union. Or you can come to us, to what we call an OECD accredited testing station, and get what we call an OECD approval number. This approval number will allow you to sell your tractor in Europe, because we have equivalence, so the European Union recognizes our certificates. But it will allow you also to sell your tractors in all our member countries, so to sell it in China, in the United States, in Turkey, for example. So this is one of the key advantages of our group, is mutual recognition. This means that a test done in China, for example, has to be recognized by France and by the United States, and the same the other way around. So as you can see, this facilitates trade, it lowers costs, it reduces time, and it helps to truly enhance trade flows amongst our member countries. But let me tell you more specifically how it works. Currently, if you have a new, if you're a tractor manufacturer and you have a new tractor model, you want to sell this new model, you can come to an OECD testing station. We have testing stations in all our member countries. By the way, each member country decides how many testing stations they want to have. Some countries have only one, other countries have up to 4 testing stations. Countries will decide autonomously according to their needs and to their markets. So you bring your new model of tractor to our testing station. There it will be tested to see if it complies with our rules and regulations. This testing station will issue a report, a test report. That report will go to what we call the OECD Coordinating Center, which is a group that depends directly on OECD of experts that will check the report and make sure that all our standards and test procedures were followed. This is an additional layer of checks and controls that we have. It's third-party certification. And we need to have this because we have a global system. So in order to ensure that a test done in China is the same as a test done in France and is the same as a test done in the United States. So this is the system that we have in place nowadays. It has been very successful. As you see, we have been operating for 60 years now. And we are going to suggest to have something similar for agricultural robots. Right now, we heard the previous discussions, if we should go into standards or not, if we should regulate agricultural robots or not. The facts are that already some countries are regulating, already some countries have standards and are developing more standards for autonomous machines, for robot tractors. So the risk that we see here is that we will have one system in Asia, one system in Europe, perhaps another system in the United States, and this is not good for trade. So we want to avoid that. So we are offering to have all together, to sit down together with Asia, Europe, and United States, and try to see if there's some common ground to develop a unique global system to certify and approve robot machines. One of the key aspects that we are suggesting is to have mutual recognition, the same way that we have for tractors. So whatever system we agree, robot tractor manufacturers can approve and certify their machines in their own country, and all the other countries will recognize that. They cannot ask you to redo tests again in the other countries. We also need to find a way to add credibility and trust to the system. So we need to discuss who is going to check that everybody's complying with the system, that all countries are compliant, and that all manufacturers comply with whatever system we decide to have. It needs to be fast, because we know that time is money, so we don't need to develop something that we will take weeks or months to certify a new machine. We need to discuss that. That's one of the key issues of this system. As I mentioned to you, there are already some standards that some countries and some organizations have developed. So we do not need to start from zero. We can use what it's already there and maybe try to see if everybody else, Asia, Europe, and United States, can agree on those standards to make them global standards, or if we need to update those standards in order for everybody to accept them. We are suggesting to focus on performance and safety on robot machines. While in tractors, we focus on the safety of the driver. In the case of robot machines, I mean, we have discussed this here, I heard it in the previous sessions. The main issues is who is around the robot machine. So people, animals, plants, we need to reach an agreement on how and who is going to check that these machines are safe for their environment. We also suggest that we should focus on performance, not performance of the engine of these robot machines, but performance in the sense that what these machines promise to do, they really deliver. I think somebody needs to check that if a manufacturer promises that their machine is completely autonomous, it recharges with sun, you will just leave it connected and they will do all the work. Somebody needs to check that that's true. This is in the interest of the consumer, but it's also in the interest of manufacturers. So we have fair trade amongst robot manufacturers. Finally, and I would like to emphasize this, we do not want to impose anything, any system, any particular standard. The way we work is that we have consultations with all stakeholders. So we invite industry. Here we have Ivo from CEMA, so he can participate in our meetings. We invite farmers associations. And we have, of course, government officials. So we all together sit down and discuss what we can do. We work by consensus. Only if all my member countries agree to do something, we will move forward. If one country doesn't agree, then we stop. And that's other of the key advantages of this group, is that all those who participate, all those member countries who participate, have veto power. So this allows everybody to discuss frankly, truly, and everybody can defend their own interests and the interests of their industry. So this is our suggestion, this is our proposal. We will have a meeting now in February at OECD in Paris. We are going to invite the European Commission. We are going to invite ISO, International Standards Organization, manufacturers associations and farmers organizations to try to see if we can sit down together and agree to start working on a unique system. As I told you, there's already systems being developed, but maybe going in different ways. So the challenge is to sit down together and try to agree that it's better to have one unique system. It will take the time that it will need, years, but the important thing is to start now and agree that what we need is only one system to allow trade, global trade of these new technologies. Thank you.
Thank you. Thank you, Jose. So Mike PANKONIN from AEM is going to talk to us.
Whoa. Well, thank you for allowing us to participate in this very informative and very well-organized meeting. I'm here to talk about a few things that are occurring in the US, and there's, I think, a strong appetite for automated equipment, highly automated equipment, robots, if you will. But there are some pitfalls or things you need to be aware of if you are going to market in North America. And that's really what I would like to focus on for a few minutes. AEM is, we have roughly 1,000 members, and we serve 5 different sectors. Agriculture is one, construction, mining, utility, and forestry. All sectors right now, this is what everyone seems to be working on. And in many ways, I think agriculture is far ahead of the rest of the lot. And there's a strong interest, even in our regulatory bodies, to see higher levels of automation in equipment. When we talk about the U.S. liability situation is something that you need to be very much aware of. Standards are considered a bare minimum. It's not what's required, it's the bare minimum. There's no presumption of conformity in North America. And really, who will decide your liability exposure should something unfortunate happen will be a court and possibly a jury. And I think that's something that if you are marketing in North America, you just need to be aware of that. And take it from the standard, which is a bare minimum, do your risk assessment and then risk abatement so that you are providing the safest product possible in North America. California, and as you know, we have a number of different states. Some of them can create their own laws. California does that, and being one of the largest economies in the world, I guess they can afford to do so. We'd like to touch base on California, and we actually had an experience in California. There's a law on the books in California in their occupational safety and health law, and I'm going to read it. My memory's limited, so I would prefer to read it directly. And this is right out of their statutes. All self-propelled equipment shall, when under its own power and in motion, have an operator stationed at the vehicular controls. That's in the law. They go on to say there are some exceptions. You can have a remote location, but if you have a remote location and you're going faster than 2 miles an hour, you need to have steering at that remote location. Another thing that we found out is that if there are no people in the area, it doesn't apply. So if you're out in a very controlled, remote area, you don't necessarily have to comply with that. And in fact, there are some companies that have approval to move forward with their really fully autonomous machines being monitored from a remote location. And they have full authority from the California OSHA to go ahead and put those products in service because it's perceived and it's in the risk assessment, these machines, as an example, are spraying hazardous chemicals into an orchard. And so some of the personal protective equipment is a little bit problematic. So it's perceived that the risk to the operator is much less, especially since it's a confined area. We believe that that requirement limits the opportunities that we have with highly automated equipment. And so we went and we filed a petition and asked them to change their law. I'd like to read what we proposed, and that was highly automated, self-propelled agricultural equipment may be operated by an operator not on the equipment and may be used in accordance with manufacturer's instructions and guidance. California plain rejected that. They wrote their own proposal, which was to say, and this is what was presented to the Cal OSHA board, it was to say that we would engage in mutual testing and in mutual research probably for about 2 years to identify what is required to be included in their statutes. We went and presented that to the Cal OSHA board. I have been fascinated by some of the discussion about labor. If you go in front of the Cal OSHA board, do not mention that this equipment will displace labor. That's a killer for the law. And in fact, there was one very loud voice which came from organized labor that said, oh, we don't like that. And we presented our case in front of Cal OSHA board and they rejected it. However, we still view that as a success because it initiated the discussion. And actually the Cal OSHA board invited us to come back, but they said, get labor at the table with you. So they wanted to see organized labor and organized labor saying this is a good thing. You still have an opportunity to go and provide the equipment in California, and that's through the process of getting a conditional approval to operate the equipment in the state of California. This Title 8, Section 441B, again, it only applies if the equipment is working by other workers. And if you request a variance, you do so per farmer. So if the farmer gets a variance, it applies to all of his cropland. You don't have to do it by location, you do it by farmer. However, each farmer that you would market to needs to receive such a variance. So again, we hope to take this up again with the Cal OSHA board as soon as we figure out how to get labor on the side of us. So thank you very much.
Thank you, Mike. So, Rohan RAINBOW for AGTECHCENTRIC is going to talk about Australia.
Thanks very much, Stéphane. Thank you again for the opportunity to speak with you about our experiences in Australia. I'll just wait for my PowerPoint to come up. Hopefully it will come. Do I need to press a button? There we go. Just to share with you, on top of working in the technology space with my business partners, I also I'm a managing director of a company called Crop Protection Australia, and that particular company works very closely with the producer industry bodies on the use of chemical technology and discussions with government around appropriate use, stewardship, and dealing with the regulatory requirements, both for its use in the field but also trade and market access issues for Australian product. So the alignment, I suppose, of pesticide use with automation is something I'm going to raise in my presentation. In the last session, I noted that Australia's market ready for automation, and that's really a key driver, I suppose, for our discussions in Australia. The thing that we don't have, though, is regulation. We have very few regulation barriers for on-farm autonomy, and that presents both a lot of opportunity, I suppose, for producers. It actually presents opportunity for companies that want to commercialise and get in-field experience with technology in Australia. The challenge, though, is that, of course, there's some uncertainty with that as well. Large-scale tractor autonomy is probably currently the key priority, but small platform robotics is equally has a focus. The Australian government actually has a principle of reducing red tape and regulation in that country. Can you believe that? It's very rare that most governments would actually approach that, but that actually is the policy of our Australian government, and to try and reduce more regulation if they can do that successfully. However, it's important to recognise, and we recognise this from an industry point of view, that you need to have the social licence to make those sorts of changes. And so as a consequence of that, we're developing an industry code of practice for field machine autonomy. I work very closely with the board as a senior advisor to the chairman and board of Grain Producers Australia. It's a peak body for the Australian grains industry. We're working together with the Precision Agriculture Association in Australia, which actually has some of the lead brains in precision agriculture and technology in our country, and also the Tractor and Machinery Manufacturers Association, and with specific representation from John Deere, Case New Holland Industrial, AGCO and Kubota. So together we're going to work on developing an industry code of practice as a surrogate for perhaps reducing potential future regulation by the Australian government in this space. To share with you, the Australian mining industry, as I mentioned before, has developed a code of practice for mine autonomy. That's been endorsed by the Western Australian government, and now it's being considered by the other governments, state governments in Australia. And that has set the scene for a code of practice approach for other industries. And so essentially agriculture is following suit with that. And what it does, it means that with the endorsement of the state government, it effectively becomes an instrument that can protect both the producer and also the manufacturing company should anything ever go to a common law court case. And that's a very good approach in our country to take. Just to share with you, and one of the reasons why Crop Protection Australia is also interested in this is that a lot of the technology is currently targeted towards the use of a chemical application, which we actually think is a good thing. It's both be better for the operator with reduced exposure. It's going to be better for the environment because you're going to have more sophisticated controls around the actual use and operation of that equipment. And that's often used in unison with other technologies such as camera spray technology, which is now very commonplace in Australia. In fact, had its origins in Australia way back in the 1980s. So that is going to be a key part of the technology going forward. The code of practice is very much around building industry confidence to provide confidence for companies to commercialise product in Australia. But more importantly, it's actually about building social licence for its use in our country. We're very conscious that there's potential risks both with the community, with the actual industry itself, and also potentially with the government around having confidence that the approach that the industry is taking is a good thing. So a key component of this social licence, this code of practice, is to build social licence for its use and be very clear about the messages and our confidence around how that's going to be used by industry. We're just with the code of practice, it's basically for terrestrial tractors and equipment. It's not for UAVs and it's not for forestry animal use. So just to be clear how that's working. And just some of the kind of components that will be included in that, it's very much about how you would adopt autonomous systems on farm, very much around the initialisation of those technologies, the training, the maintenance, the operation, and also the incident reporting when things go wrong. We want to have a very clear and agreed process in industry. If there are things that go wrong, how we're going to report that and how we're going to communicate that to the appropriate authorities. And we need to understand how that meets with other supporting legislative provisions, particularly in terms of pesticide application and use in our country. So, and as we move through this code of practice development, we'll certainly be taking account of the ISO standards that are developing and other programs going on globally. But more importantly, it's going to provide a foundation for producers and industry about how they use this on farm. And again, we're hoping that by developing this code of practice, it will provide a foundation that will enable companies, both in Australia and from overseas, to come and commercialise in our country. Thanks very much, Stéphane.
Thank you, Mike. So I hope you found interest in this in these talks. Maybe I'll have a question to our speakers, and then we'll switch to your questions. The one I will pick up is that if we talk about the new machinery directive, so what do you think of the role of a supervisor that will be in charge of the mission, and the latter, depending on the level of autonomy of the task performed?
Thank you for the question, Stéphane. I think we already discussed a little bit in our groups, and so who do you have? You have an owner of a machine, you have the employer, you have an operator, you can even have multiple operators. So it depends on how you look at it. So if it's a supervisor in the sense of the legal way, you need to have one responsible. Or you can have multiple responsible if you have two owners or whatever, okay. But you need somebody that can say, I'm the final responsible person, that I give the yes to the way that things are running in this farm or contractors or whatever. But then also there is the issue of the supervision of the vehicle itself, of course, where you can have multiple operators working at the same moment on the same machine. Or that you have a local operator and you have a remote operator. So who will be the one that has most priority? So that needs to be specified by the manufacturer, and he needs to make sure that if that's possible, that he will indicate what the line of actions are, and if there is any safety risk, of course, he needs to make sure that it's covered. And it can be part, of course, of the training, of course.
Okay, thanks, Ivo. So there are many ways of scenarios and dealing with the people involved in the machine, in the mission. So maybe as we are a little bit short in time, unless you want to add something, we'll go to the question session, and you will answer also.
Yeah, let's take a 10-minute session for questions and answer with the audience. So there will be some microphone, I hope. Yes, ready for you. Questions? And if not, Stéphane, you can go ahead with your questions. Anybody has a question? No, doesn't look like. Stéphane, you have more questions?
I have a question.
Sorry. Hi.
That's okay. David Verbata, Meister Media. My question is for Mike, but I'm interested if the other panels have an answer as well. I was interested in what you said about justifying the labor equation with the Labor Party in California. I think many of us, as these talk about efficiencies, we can only talk about efficiencies if we address that labor question about pulling labor up through the value chain. And I'm wondering if you could share your talking points as to how you will address the reality that technology will reduce some jobs, but on the upside, they could create better jobs.
Yeah, I think that the main thing we need to focus on is the safety of the operator. There are certain areas that where you want to keep the operator out of harm's way, and I think that really needs to be the focal point. To replace labor, it's a losing argument, at least in California. And actually, one of the board members, he made the comment because there was another person not involved with us who said, we have a labor shortage. And one of the Cal OSHA board members said, I completely disagree. What we have is a shortage of good paying jobs. So, to me, it's a brick wall. We need to focus on the safety of the operator.
Looking at the European side, but I think if you go to the extreme, to the Japanese side, in Europe we really have a huge issue of aging of population. In Japan it's even worse. So certainly in Japan, and also there's not so much bottlenecks for robotics. It's very well accepted, but they really see it as the solution for their aging problem, and for actually attracting younger people then as well to the sector. And I think it's the same here in Europe. So here in Europe, definitely it's not a problem of replacing labor. It's rather to ensure that first of all you be more flexible to do other things that you might not be doing with labor, but also of course to replace labor that is just too cheap to find the people to do it. And often very skilled jobs. And we have the example here in the room on strawberry picking. You need 2 years to train people to do it really in the right fashion. So if you then you cannot pay these people, then you will see those labor-intensive sectors moving away. So it's for keeping the specialities here, the specialty crops.
I can share from an Australian point of view, Stéphane, that the driver in Australia has also been safety, because our safety record in general isn't great, and if you remove the operator, it improves those scenarios. But the other part of it has actually been the well-being of the operator, because our systems in many industries, both in the vegetable industry and broadacre, are so highly automated already. You've got an operator sitting in a vehicle with nothing to do, and it's actually hasn't necessarily been good for the well-being of the operator to sit there all day with not much to do except watch TV or movies. But that assumes that they've got some sort of connectivity, and unfortunately in Australia, 40% of our producers actually don't even have a mobile phone because they have no in-field connectivity. So that is a key consideration as well.
All right, another question maybe? Yes.
Hello, I'm Enno Dilberg from Germany. We are an upcoming robot manufacturer for agricultural robotics, coming from the University of Applied Science Aachen. And Mr. Hostens, you mentioned that the machine directive is appropriate way for certifying the robots for safe use in agriculture. But I have some questions about that. So it's maybe a little bit technical, but there's some examples. For example, that having bumpers in front of your robot then are meant to go on the height of 20 centimeters, totally doable for industrial applications. But on the field, you have the crops at this height, and the same goes for laser scanners for safety. So right now, we as an upcoming manufacturer are looking into these problems, and we don't have a solution. So we are going with totally crazy AI-based cameras and thermal and lasers and all these multi-thousand euros sensor systems and trying to tackle the safety requirements there. But on the other side, then the German institutes, the TÜV and all the people, they're coming and saying, oh, you cannot use really artificial intelligence in your safety systems. So we are having a little problem there, complying to regulations to build fully autonomous agricultural robots. Do you have any advice for us where to look or what type of technology to use to really build fully autonomous robots?
Well, first of all, to specify, of course, that when we say that the machinery directive is suitable, it means that you can apply it. That doesn't mean that technical solutions might be there, of course. And yeah, it is an issue. And that's also the reason why we are developing these guidelines as we are doing, just to make sure that we can go for a certain level that is, let's say, affordable. And of course, then the other thing is that we need to check what is available in other sectors that they are able to use, certainly in the automotive sector. In terms of getting sensors a tenfold cheaper than it is currently. So in that sense, we are also waiting, of course, what's happening there. But a specific solution, I unfortunately cannot provide. I'm sorry, but maybe there are other people in the room that can support.
I remember when we talked with Mike, you talked also about the mining system, that you were in the US impressed about the way machines were developed, and maybe you've got something to say about perception systems in the mining industry in the US. I don't know.
Yes, we do, and I deal with the mining group, and we have met with the regulators, MSHA, which is the Mine Safety and Health Administration, and they very much want to see us move into more autonomy when you consider collision awareness or collision avoidance. So that brings up the question of how accurate does it need to be, which is a discussion we're having with CEMA and some of the standards work. And is as good as a human operator, is that good enough? Anything that you do better, a machine is not going to fall asleep, it's not going to get bored, so we view that as being positive. An assistant secretary, he very much wants to see something move forward with that, but our belief is that the level of perception and the accuracy of a system needs to be much better than what you would see with a human operator, although we really can't define what a human operator can see either because there's so much variance there. So the point being, we need to have a very, very high level of reliability in the sensors. And having just bought a new vehicle, the other thing that happens, I bought a 2019 vehicle, the weather gets bad and the sensors shut off, or I get spurious signals that are no good. And if you have that in a production application, I was interested in the discussion from earlier, you can't shut down a multi-million-dollar mining site or agricultural operation because you have snow near. That's not really a good thing. So I really question how long is it going to take to advance to a point where the sensor technology is sufficient that we can rely on those technologies.
All right, we might take another very last question in the audience. Is there a question? Or Stéphane, do you have one last question maybe? No? All right, well, if not, thank you. Would like to thank all the gentlemen warmly for this very informative roundtable.